Okay. So again, we started with this equation. If I have m number of constraints, equation of constraints, you should incorporate it to Euler-Lagrange equation, and then solving next is you're going to solve for the lambda. The lambda there will be the the so-called Lagrange multiplier. Okay, so there is this um, um, derivation. So the starts are always from the using the variational principle J, no? And then from that, uh, natin makuha ang equation na ingani. And then since the left side is independent, since the left side and the right sides are um, implicitly time dependent, so you can actually equate it to a function lambda. We call that one as lambda, where lambda is a function of time. Generally, it is a function of time. Pero pwede po siya dili function of time. Pwede po siya constant. Okay? Basta lang, it is a function of, say, pwede sa constant or a function of time. Okay? So if you equate this, the left side, you equate it by lambda t, you will get the first equation, this one. And then if you equate the right side of the equation, you will get this, no? Na partial L, partial of Q2 equal to lambda, which is a function of time, partial f with respect to Q2. So, kung lang taon nimo na sinadungag na term, this is the Euler-Lagrange. Okay, so muna akong Euler-Lagrange, no? Tapos na sinadungag na term, and this term is, we call this as Lagrange multiplier. So, if you do um, substitution, by the way, I just call it as negative, okay? I-let na ko siya as negative gamma t, lambda t, sorry, lambda t, para pag transpose din mo sa PCAS, may mo siyang plus. Anyways, it's just a sign, no? So, ikaw bahala. Uh, para pag transpose ako sa PCAS na side, the minus lambda t becomes plus lambda t. Okay? So, again, you can set this as any function which is a function of it. You can let this whole term sa left side or sa right side as a function of time t. Okay, the negative sign is just some constant, okay? Negative one. Okay, such that as you can see here, if you transpose the lambda t, what will you get is this one. Okay, partial L, partial Q i's minus d dt of partial L, partial of Q i's dot plus lambda, which is generally a function of time, partial of f with respect to qi equal to 0. Okay, so this will be our new Euler-Lagrange now. Okay, so nakay gidungag nga sa atong gidungag, ang gidungag na to is kaning the third term, which is we call this one as the Lagrange multiplier. Okay, so where I call that one as qi lambda t partial of f. Take note, si f is that the equation of constraints. Okay, we call this one as the Lagrange multiplier. Okay, Lagrange multiplier. Okay, so depende na lang dayon kung pila ka po generalized coordinates nimo, no? Say for example, if I have two generalized coordinates, then you also have um, two equations, okay? Tama, with respect to Q1 and with respect to Q2, okay? So, first is you need to set up the equation of constraints, and then lantawan mo kung unsa mga coordinates ang imong function, ang imong equation of constraints. Say pwede siya function of say xyz or a function of spherical r theta phi and so on. Okay, so what will you do is just derive it with respect to the generalized coordinate qis. Okay, so you can solve for this, ma-derive nimo na yung partial f, partial qis, and then the goal is to solve for the lambda, and once you solve for the lambda, the final goal will be the equation of motion. Take note, uh, this is an alternative method in order to calculate the equation of motion. Okay, so katong niagi, ang atong gibuhat is gi-incorporate nato daan ang equation of constraints para ma-reduce ang ato ang generalized coordinates, no? Because na kay m minus n. m degrees of freedom, m generalized coordinates minus n equation of constraints, ma-reduce siya into pila ka mo coordinates ang mabilin. Okay? In this case, wala na ito gigamit, wala na ito gi-incorporate daan ang force of equation of constraints, but gi-incorporate na to siya sa atong Euler-Lagrange equation ano mismo, no? So, naa na siya direct. Naa na siya dire sa akong equation. Okay? So, instead nga, as, I think kanino, pinagay ko. Ito example. Kanino, I have, uh, in general, I have 9 degrees of freedom there. Okay? But, since na ako'y tulo ka equation of constraints, ma-reduce na siya into 6 generalized coordinates. But if you use Lagrange multiplier, there are actually 9 generalized coordinates. And so therefore, napo kay 9 ka equations for your Euler-Lagrange. Okay, so let's try to solve problems using Lagrange multiplier. I-check na to, i-compare na to ang duha, no? First, is i-solve na ko siya using atong Euler-Lagrange lang without Lagrange multiplier, and then the second one will be using this Lagrange multiplier. Say for example, I have this problem. Dapat same na sila makuha ang answer, no? Dapat same na sila makuha ang answer. Um, ang goal lang man is to solve for the equation of motion. Okay? Say for example, we have this problem, a yo-yo. Yo-yo man siya, yo-yo sa forma. Oops. Okay, kani. Tignan mo. Ito. Okay, this one. Say for example, this one. Okay. Oops. Gani. Paano ni siya, no? Okay. Say for example, solve na to sa duha ka method, no? Method 1 is katong usual na to nga pag-solve ani. And then method 2 is you will use Lagrange multiplier, okay? Okay, then let's try. Okay. So I have this problem, a disk that has a string wrapped around it with one end attached to a fixed support. So ang iyang figure looks like this. Okay, so na ko yan. So mara sa yo-yo yun, no? I-release nimo ang katong disk. Then what will happen is there is these two kinetic energies, no? Nakoy duha ka kinetic energy. The translational going downward, and at the same time your disk is rotating pana, no? So makita nato na there are um, two numbered of degrees of freedom, but since there is this force of constraints, ako isa ka equation of constraints in which related imong y ug ang imong phi. Okay, so ang mahitabo kung di ko magamit og Lagrange multiplier, duha ka generalized coordinate, ano, kung di ko magamit og Lagrange multiplier, isa lang ka generalized coordinates, yung sakto ba? Because I have nakoy the generalized coordinate here is 3, tapos minus duha ka equation of constraints, which is katong z equals 0, and then relationship between y and phi, you will get the equation of motion coordinates. Okay, so muna akong ang system. Okay, and then there is this, oops, as you can see here, the kinetic energy, it has two expression. Okay, na ko duha ka expression. But first I will put the equation of constraint. Equation of constraint. Actually duha siya, no? Pero isa lang ko ibutang because ang isa is z equals 0. Wala kay makuha ani nga information sa imuhang equation of constraints sa kaning z equals 0. Ang isa is this. Ako'y f which is a function of y and phi equal to um, uh, y which is equal to a times phi. Okay, so this is the equation of constraints na there are two, but ang imuha lang makuha, ang ako lang actually makuha nga equation of constraints isa lang kanila. Again, z equals 0 is just you cannot do anything about this equation of constraint kan z equals 0. So only this one kanila akong consider. Okay? So the equation of constraint is na ako y is equal to a phi, tama ba? Because as you can see from the problem, your y is related to phi by this equation where a is the radius of your disk. Okay, so therefore, uh, you can have this f as if you transpose the a phi, we have y minus a phi equal to 0. So I have now an equation of constraints. Isa ka buo. Okay? Again, duha pero walay, di na nakuha ng z equals 0. Okay. So I have now the function f. Take note, f is an equation of constraints. So question is what will be the equation of motion of this given system. I will solve this one using two methods. First is katong atong usual nga auto-naval Euler-Lagrange, and then second is I will use Lagrange multiplier. Okay. Method 1, just this. Na ako'y ito lang ato ang nibalan last time, no? I have first is get the Lagrangian, which is equal to T minus V. Again, there are two kinetic energies. We have 1/2 m y dot square plus 1/2 the moment of inertia times the pi dot square. Sakto ba? The translational kinetic energy, and the other one is the rotational kinetic energy. Okay? So again, based from this, makuha na to na nasa rotational kinetic and at the same time nasa translational na kinetic energy. First term is your translational, while the second term um, is your rotational kinetic energy. Okay? With respect to phi. Take note, I here is the moment of inertia for disk. This is disk. Tama ba? Disk ba ni? Yeah. Wrong spell na akong disk. Yeah. See the initial spell. Okay. So this is disk. For this, given ang iyang moment of inertia, it is equal to 1/2 m mass of that disk times the radius square. Okay. So again, fix na ni mo ang moment of inertia for this. It's equal to 1/2 ma square. But take note, a is the radius of your disk. Okay, the radius of your disk is a. The mass is m. Okay. So if I substitute I disk equal to 1/2 ma square, then kulang pa ko og potential energy, no? The potential energy is na ko'y m minus mgy. Okay, sakto ba? The potential energy is minus mg times y. Because this will be your ground, this will be your origin, then your disk is below the origin, so therefore the potential energy is minus mgy. So therefore, the Lagrangian now is just equal to this 1/2 my dot square plus 1/4 um, m a square pi dot square plus mg times y. So this will be my Lagrangian. Okay. So if I do okay. So diri na kalahian sa kung mogamit og Lagrange multiplier o dili ko mogamit og Lagrange multiplier. I will first incorporate sa to akong ingon gaya no. I-incorporate na ko ang equation of constraint sa Lagrangian in order to reduce the variables, in order to reduce the generalized coordinates. Okay? So in this case, duha man ka generalized coordinates, no? Na ako'y y and phi, sakto? So I have two generalized coordinates, generalized coordinates y and phi can be reduced into into one, okay, using the equation of constraints, equation of constraint f. Okay, so ako ana daang gigamit si f. Okay, gigamit na ako si f, so itong f gana ko y minus a phi equal to 0. In this case, y is equal to a times phi. Okay, so I will use this. Okay, tapos i-substitute na ko sa ako ang Lagrangian. Okay, i-substitute na ko sa ang Lagrangian. What will happen? Take note, if y is a phi, then y dot is just equal to a phi dot. Sakto? So, if I substitute this one to our Lagrangian, L becomes what? Si L kay mahimo siyang 1/2 my dot square plus 1/4 m a sa dili. Unsa akong kanon? Y or phi? Okay, phi na lang, no? So, phi akong gamiton. So, y akong substitute, no? Mag-substitute ko y. Y dot. Okay, so I have a phi dot, okay, square plus 1/4. Sorry, it's 1/4 ma square phi dot square plus mg, ang akong y is a times phi. Okay, a times phi. So in this case, you can now reduce, okay, you can now reduce the generalized coordinates instead nga duha ka buok in terms of y and in terms of phi, isa na lang ang imong function, isa na lang imong generalized coordinates, which is just a function of phi na lang. So in this case, if you simplify this one, we have ma square phi dot square, okay, plus 1/4 ma square phi dot square, and then the last one is mg a phi. Combine mo ang duha, no? 1/2 plus 1/4, that's equal to 2 over 4, 3 over 4. No? So therefore, si Lagrangian now, it's just a function of theta, and theta dot is equal to 3 over 4 um, m a square phi dot square plus mga phi. Okay. So this will be now your Lagrangian. Okay? So isa lang, no? Isa lang ka bukihang generalized coordinates, isa lang ka independent variable ang nasa akong system. And that is equal to that variable is a variable phi. Okay? So again, ang kalayaan niya is i-incorporate ni mo daan ang equation of constraints sa imong Lagrangian. Ang katong Lagrange multiplier is wala nimo wala nimo i-consider ang f sa L, but i-consider idungag nimo siya sa imong Euler-Lagrange equation. Okay? Not dili sa Lagrangian, but sa Euler-Lagrange equation. Take note of that, no? So, using usual Euler-Lagrange, so therefore equation of motion is just this. Equation of motion is na ko partial L. Isa lang kabog equation, no? With respect to phi minus d dt of partial L with respect to phi dot equal to 0. So in this case, if I derive L with respect to phi, you will get mga minus d dt of, if I derive phi dot, what will you get is na ko 3 halves ma square phi dot equal to 0. Sakto? A phi, okay. Correct. And then if I derive it again with respect to time, what will you get is na ko mga minus, ang phi dot may akong i-derive, 3 halves ma square phi double dot phi double dot. Okay. To solve for mo cancel si m, can cancel out the m. Okay. So mahimo siyang 3 halves a square phi double dot equal to g times a. So therefore phi double dot is equal to 2 over 3 g over a. Sakto? So this will be your phi double dot. So this will be the equation of motion for this one. 2/3 g over a. Sakto? Kaya mag-cancel out mo na isa ka a, no? Cancel out mo na isa ka a. Okay? So nakoy g over a. Okay. And then, you know that there is this relationship between y and phi. Okay, since y dot is equal to a phi dot, then therefore y double dot is just equal to a phi double dot. So if you do this, you will get a times 2g over 3a. This is just equal to 2/3 of g. Okay, so your y double dot, so therefore your y double dot, okay, is equal to 2/3 times g. Okay, mo po ning nakanindot kung mogamit kog Lagrange multiplier, makuha na ko tanan equation of motion. Okay? Whereas kung dili ko mogamit og Lagrange multiplier, gi-reduce na nimo daan ang generalized coordinates. So, ang imong buhaton is once makuha nimo ang isa ka equation of motion, then use the equation of constraint to solve for the equation of motion for the other coordinates. Okay? So, yeah. So, we now have the phi double dot and the y double dot, which is equal to this one. Now, let's solve this one using using this method 2, kaning using Lagrange multiplier. Tanaw na to kung parehas ba sa answer, no? Take note y double dot is 2/3 a g, while phi double dot is 2/3 g over 8, g over 8. So let's start solving this one using method 2. Dapat same na sila answer, no? Method 2, Lagrange multiplier. Okay, Lagrange multiplier. Okay. We know that the original Lagrangian, is given by this. L. This is with respect to y and phi. Y dot and phi dot also. We have 1/2 m y dot squared plus 1/4 m a square phi dot square plus mg times y. Sakto. So, muna ako ang Lagrange, no? With respect to this, wala pa nimo gi-incorporate ang equation of constraints. Okay? So, kani, no? Pa nimo gi-incorporate or gi-incorporate ang equation of constraints. So, sa itong sa Lagrange multiplier, instead of using the equation of constraints and then incorporate it to Lagrangian, you have to incorporate it to the Euler-Lagrange equation. Okay? So take note, this is my L. This is my L. Okay, this is my L. And then, take note the equation of constraint. Isa lang kabuok, no? Equation of constraint is na ko F, which is equal to y minus a phi, equal to 0. Okay. And then, kung sa itong or Lagrange multiplier na to, ingani, no? Partial L with respect to, there are two, no? There are two Euler-Lagrange equation because na ako'y duha ka generalized coordinates dari, na ako'y y and phi, sakto? Again, wala nimo gi-incorporate si f dira, so therefore the original generalized coordinates is in terms of y and in terms of f. So in terms of phi, sorry. In terms of phi. So therefore, there are two, ako'y duha nga makuha nga equation. I have this with respect to y, okay, duha ka buok. With respect to y and then with respect to phi, okay? So na ako partial L with respect to y minus d dt of partial L with respect to y dot plus the lambda, okay? The lambda partial f with respect to y equal to 0. Okay, take note, lambda is any function. It can be a function of time or it can be a constant. Okay, and then for phi, na ako partial L, partial phi minus d dt of partial L, partial of y dot plus lambda partial f, partial sorry, this is phi. Okay, this is phi, sorry. Okay, partial of phi dot and then this one is partial of phi equal to 0. Take note, isa lang kabuk akong equation of constraint. So therefore, isa lang po ang ako ang lambda, isa lang po akong term nga no? Kaya siya nga term. Okay? If I have two equations of constraints, then ako ang buhaton is i-add mo ang mag-add ko duha lang. So for example, no, sulay na to, no. Ningon ko last time na I have two equations of constraints. We have that. Okay? And then I also have y minus a phi equal to 0. Okay? So, na ako'y duha ka equation of constraints. This is my F1 and then this is my F2 for example. But again, ningon ko gaya na nga, this is useless because if you use Lagrange multiplier, what will happen? In terms of y, na ako'y partial of y, L with respect to y minus d dt, um, partial of L with respect to y dot plus I have two equation of constraints so na ko'y duha pod ka buok lambda. I call this one as lambda partial f with respect to y plus this is f1, sorry, this is f1, and then lambda 2 partial of f2 with respect to y equal to 0. Okay. So, ningon ko nga useless ning akong f1. It is because, as you can see, if you derive f1 with respect to y, this is equal to 0. Sakto? Because uh, your equation is just z equals 0. If you derive it with respect to y, this term will be 0. So that's why, ningon ko nga, if na ko z equals 0 nga equation of constraints, then you can actually omit that. Okay? Because later on, mag-cancel out lang gyapon na sa imong equation. So that's why, uh, kanila ang nabilin, no? Kanila lang din ang nabilin katong lambda lambda partial f with respect to y and then lambda partial f with respect to phi. So if I have five equation of constraints, then summation lang nimo, no? Nako summation of lambda i's partial of f i's with respect to q i's dra. So if I have five equation of constraints na po ko'y lambda 1 partial of f1 with respect to q1 plus lambda 2 partial of f2 with respect to q2 plus and so on. Okay? Kung naghan kong equation of constraints. Later on, maghatag example na I have two equations of constraints para makita na to niya, no? So, this take note the lambdas, okay, take note kaning lambda 1, lambda 2, lambda 3 are called the Lagrange multiplier, okay? The lambda 1, lambda 2, lambda 3 are called the Lagrange multiplier. In our problem, there is only one equation of constraint. So therefore, isa lang ka lambda akong makuha later. Okay? So I just call it as lambda. Di na lang ko magputang og lambda 1 og f1 because isa ra man ka bukaw equation of constraints. But later, if I have many equation of constraints, then I can use the lambda 1, lambda 2, lambda 3, partial f1, partial f2, partial f3, and so on. Okay? So, in this case, isa lang ka buok. So, I have lambda partial f with respect to y and lambda partial f with respect to 5. Okay. So, unsay na? Same lang man ni siya, no? Kani, partial, if you derive the L with respect to y, so makuha nimo with respect to y, this is just equal to m times g, sakto? Minus, with respect to y dot, this is equal to my double dot. Sakto ba? D dt of partial L with respect to y dot is just equal to this my double dot plus lambda is unknown. Take note, lambda is unknown and we are going to solve that later. Okay, lambda is just lambda. It is it is a function of time or a constant. And partial f with respect to y, you look at this one. As you can see from this equation, if you derive y minus a phi with respect to y, what will you get? Your answer is just equal to 1. Sakto ba? I-derive din mo si y minus a phi equal to 0. With respect to y, your answer is equal to 1. And this is equal to 0. Okay? Next, if I derive partial L with respect to phi, this is 0, right? Because ang imong L is not a function of phi. Okay? Wala kay makita nga phi nga function dira. Okay? So, minus, if I derive the phi dot, what will you get? Na ko'y 2 times 1/4, that's 1 half. So, na ko'y 1 half m a square phi double dot. Sakto? Na ko'y phi double dot dira. Plus, the lambda times what's partial of f with respect to phi? Based from this, tanawin mo ning equation. Unsa ako ang derivative of my f with respect to phi? Pila answer?
Negative A, sir.
Negative a. Yeah, that's correct. That's correct. It's negative a equal to 0. Okay. So I have this. Then you have to. Your goal is to solve for the lambda, and once you solve for the lambda, you can solve for the equation of motion. And let's check kung parehas ba sila og answer. Okay, so tanawon na to, no? Uh, ito. Okay, so I have mg. Ako daw ka equation, no? Oh, sorry. Okay, so I have two equations, no? Ako mg mg minus my double dot plus lambda equal to 0, and then the other one is minus 1 half ma square minus 1 half ma square pi double dot minus lambda times a equal to 0. Okay, and then you have to solve for we also know, take note, you also know that your y, okay, your y is equal to a phi. Therefore, y double dot is equal to a phi double dot, and also y double dot is equal to a phi double dot. Okay, so we know this one. So if I have, take note, I have three variables here. Okay, nakoy tulo ka variables, the y double dot, the phi double dot, and then the lambda. Tama ba? The y double dot, the phi double dot, and then the lambda. I have three unknowns. I only have two equations, so that's why we can use this. You can use this relationship sa akong equation of constraints para ma-fill-in aning ako ang kulang na equation sa kani. Ito lang man ikaano, no? Phi double dot, y double dot, and the lambda. So I will use this para ma-reduce into 2 and then solve for lambda. Okay, so if I use this, y double dot is equal to a phi double dot, what will you get from here? Ako'y mg minus m a phi double dot plus lambda equal to 0, and then the other one is minus 1 half ma square pi double dot minus lambda a equal to 0. So, ang goal is to solve for the lambda first. Okay, solve for the lambda. From this, makuha na ko si phi double dot. Kila si phi double dot ani, this is equal to lambda over m. Sakto ba rin? Lambda over m a. Tapos na ko 2 dira. Sakto? Yeah. Lambda tanaw sa dito, tapos multiply na ko sa by 2. Na negative. Napay negative, sorry. Napay negative. Okay? Negative a ma. Yeah. So that's my pi double dot, and then I substitute this one there. Okay, substitute na ko dira na ko mg minus ma times minus 2 lambda over ma plus lambda equal to 0. Okay, equal to 0, so mag-cancel out ni. Okay, so therefore na ko mg minus minus is plus, so na ko plus 2 lambda plus lambda equal to 0. So lambda here is equal to 3 lambda minus mg, so therefore lambda is equal to 1/3 of the mg. Negative ba? Nakuha ba sa dili negative? Dili negative asa ba? So nakuha negative. Sakto na na. So the lambda is negative mg over 3. So this is the Lagrange multiplier. Take note, one of the goal is to solve for the Lagrange multiplier. Okay? So again, if na ko'y duha ka equation of constraints, so na po ko'y duha ka Lagrange multiplier. Lagrange multiplier. Okay? And it's equal to minus mg over 3. So nanin sa kung mag-exam ka, naging sa isa ka section dira nga calculate the Lagrange, calculate the lambda. Okay? Solve for the lambda. And then, since na-solve na ko si lambda, take note si phi double dot is equal to that. So we can solve for phi double dot, which is 2 gamma over MA. So we have minus 2. Your gamma is minus mg over 3 over MA. Mag-cancel ang negative. Mag-cancel si M po. Mawala si M. So as you can see, your answer is equal to 2 over 3 G over A. Which is, muna ito nakuha katong sa method 1 nga itong gigamit. Okay, si phi double dot is equal to 2/3 G over A. And si y double dot, sorry. Y double dot is this. Y double dot is a phi double dot. Phi double dot is equal to a phi double dot. So this is just equal to a times 2 over 3 G over A. Cancel si A. Delete, wala negative. Sa negative. Okay. So y double dot is equal to 2/3 of G, which is again, muna ito na solve using the method 1 without the Lagrange multiplier. No? Ako'y 2/3 G, and then na ako'y 2/3 G over A. Okay? So, ang naalang, ang nadungag lang is this lambda. Okay? So, ang nadungag lang is this lambda. You can solve for the Lagrange multiplier lambda in your system. Okay? Yeah, and that's it. That's the Lagrange. That's the what alternative method in order to calculate the equation of motion. We call this one as Lagrange multiplier. Okay? Clear? Clear ba? Okay, let's do this one good example. Let's do this one good example. Now we have time enough. The time enough. Pwede na ito dito iwason, no? So, okay, let's do this one. There's this one good problem. This one. Wala ko'y soft copy, but ingani sa forma, no? Consider the system, for example. Example, we have the system in cylindrical coordinates. Okay, in cylindrical coordinates, I have a bead of mass and it is constrained to move along a smooth helix wire without friction under the influence of gravity. So, na ako'y mass, okay, and then ang iyahang motion because of the gravity going downward, ang iyahang motion is ingani sa forma, no? The mass M is constrained to move along a smooth helix wire. Helix wire is, it looks like this. Okay. Okay. So, padulong sa ubos. Okay. Ang iyang motion is going downward. Your mass here, kanina mass, your mass here is what? Is going downward. Okay. Pero, downward siya pa spiral. Okay. So, downward siya pa spiral. So, etc. Okay, so that's the system. Mora yung system, no? Um, yeah, mora yung system. Under the influence of gravity, your mass M moves uh, in a helix, yeah, in a smooth helix wire without friction under the influence of gravity. The wire shape is described in a cylindrical coordinates. Cylindrical coordinates is given by this. Nakoy R. I will use R, not phi, rho, sorry. R, phi, and z. So this is in cylindrical coordinates. Cylindrical coordinates. So as you can see here, I have originally si mass nimo has 3 degrees of freedom. Okay, 3 degrees of freedom. But in this case, I have two equation of constraints. Okay, 3 degrees of freedom man sa no? Nakoy R, phi, and z. Pero nakoy equation of constraints, nakoy duha, no? Equations of constraints, I have two. Okay, equation of constraints. First is we have Z equals K phi, and then the other one is R equals fixed radius of R. So, ang radius ay mong helix. The radius of your helix here is fixed. The radius of your helix is fixed, which has a radius of if you look at the top view, your helix has a radius of equal to big letter R. So I have two equations of constraints. So therefore, ma-reduce siya. If I will not solve it using Lagrange multiplier, then therefore, ang kaning mass nimo has only one generalized coordinates because of these two equations of constraints. Z equals K, phi, and then R equals R. Okay? But usahay, for example, kung ang problem nimo is a helix, pero ang helix kay nga forma, okay, mag-vary mo R, then ang mahitabo is only one equation of constraints, wala na yung imuhang R equals R direct. Okay? So, posible nga na yung form, no? So, yung mong helix kay nga ni forma, no? Lahi mo lahi ang ang radius ay mo helix. Anyways, parila sa no constant na radius lang. Okay? I have equation of constraints do ka po. So I will let this one as F1, okay? And then I will let this one as F2. Okay? So my F1 is this. Oops. Okay, F is equation of constraint, no? So I have two equations of constraint. So we have Z minus K phi equals 0. And then the other one is R minus R equal to 0. Again, na ako'y duha ka equation of constraints. Na ako'y Z minus K phi equal to 0. And then the R minus R equal to 0. Okay. So, if I use method 1, ang nakamaot sa method 1 is makakuha lang isa ka equation of constraints, but anyway, isa ka equation of motion. Okay, makakuha ka isa ka equation of motion. But dili ka kuha atong duha. But makakuha rin to ay hindi mo to siya using this. Makakuha rin to using this one. Okay, anyways. So let's try to solve this one using the Lagrange multiplier. Okay? So i-try natin yun sa using the method 2. Okay? Method 2. Hindi na ako mag-method 1. Okay ra? Okay, sa'yo naman ang method 1. No? Just use this. Then substitute this one to Lagrangian. It will reduce into, one generalized coordinate. It will reduce into one generalized coordinate and then use one Euler-Lagrange equation. Then you will solve for the equation of motion. Okay? So I will use Lagrange multiplier here. First is you need to express the Lagrangian. Tama ba? The Lagrangian of this one, the Lagrangian is given by this. L, you can solve for the Lagrangian. I have three kinetic energies here. I have, this is my x, y, z. This is my z. Kani siya kay z na ko ni. Kani siya is x and then kani siya is y. Okay. In cylindrical coordinates, I have three kinetic energies. Translational along R. Okay. Na ko translational nga kay move man hang mass pa R, no? From 0 to R, move mo hang mass from 0 to R. At the same time, move siya downward with respect to Z. Sakto? So I have two translational kinetic energy. Akong mass is mulihok pa na with respect to R. And then, ang mass po na ako is mulihok translationally with respect to Z. So I have two translational kinetic energy and one rotational kinetic energy. Because take note, your mass M is also rotating with respect to phi a variable. Okay? So I have three kinetic energies, one half translational for R, okay, and then translational for Z, and then rotational for with respect to phi. This is equal to one half R, not one half M R square phi dot square. Okay, Tama? So the first and third term are the translational kinetic energies, while the second term will be your rotational kinetic energy. Okay? Again, mo translate siya with respect to R, then mo translate siya with respect to Z, and then the last one is mo rotate siya with respect to phi. So that's why nakoy angular velocity equal to R phi dot. And take note, angular velocity is phi dot, the linear velocity is R phi dot, and take the square, you will get the rotational kinetic energy 1 half m r square phi dot square. Okay, so that's the kinetic energy, while the potential energy is just this mg times z. Sakto? Because your mass is located above the origin, which has a position equal to z lang. Okay? So na ko minus mg z. Okay? So this is now the Lagrangian. Okay? So na ko ingat. Okay? Again, if you use method 1, if I use method 1, just substitute z is equal to k phi, and then r is equal to big letter R, you will get a the variables, this r phi z will be reduced into one single variable, and I think ang mabilin is only phi. Okay, so it is just your Lagrangian is just a function of phi. Okay, so kamo na bahala na no sa method number 1. So isa lang ka phi, and then using Euler Lagrange you can solve for the equation of motion. Let's do the Lagrange multiplier, no? Lagrange multiplier. Multiplier. So, pila ka buok imong equation nga makuha? Pila ka buok ang equation nga imong makuha? There are, pila ni? Since I have three generalized coordinates, I also have three Euler Lagrange equation with Lagrange multiplier. Okay? So, na with respect to R, na partial R, L with respect to R minus d dt, partial L with respect to R dot, plus duha ka book ako ang lambda, because take note na ako'y duha ka equation of constraints. So na ako'y lambda 1 partial f of 1 with respect to R plus lambda 2 partial of f of 2 with respect to R equal to 0. Okay? And then for in terms of phi, na ako'y partial with respect to phi minus d dt partial with respect to phi dot, and then plus lambda 1 partial of f1 with respect to phi plus lambda 2 partial of f2 with respect to phi equal to 0. And the last one, we have in terms of z, partial of L with respect to z minus d dt of partial L with respect to z dot plus lambda 1 partial of f1 with respect to z plus lambda 2 partial of f2 with respect to z equal to 0. Again, I have three equations, and then do the math, do the derivatives. Okay, like for example, what is partial of f1 with respect to r? This one is equal to 0, right? With respect to r, si f1 is just a function of z and phi. So therefore, in this case, this one will be 0. Sakto? Tama ba? Si partial f1, kung kanya ko ng tawon, if I derive this with respect to r, then that is equal to 0. If I derive f2 with respect to r, then that is equal to 1. So, kani siya kay mahimo siyang 1. Okay? Kani siya kay mahimo siyang 1. Okay? Partial f1 with respect to phi, with respect to, this one is 1. This one, saan siya? Mahimo siyang partial of f1 with respect to phi. Pila answer?
Negative K.
Negative
Negative
k.
K.
Yes, that's correct. So, negative k. And then, partial of f2 with respect to phi, this is 0. Sakto? Partial of f1 with respect to z, that is equal to 1. Sakto? 1 sa no? 1. Tama. With respect to z man. So, ang isa, partial of f2 with respect to z, this is equal to 0. Okay? And then, yeah, do the math, you will get the answer. Tama. So, this will be your assignment. Okay? this will be your assignment. Assignment is ako lang gihatag daan ang iyahang answer no sa kaning derivative sa imong f1 with respect to r, phi, and z. Your assignment will be this one. Assignment. Okay. Assignment. So this is a good practice, no? This is a good practice sa inyong derivatives assignment. So for lambda 1 and lambda 2, okay? Solve this. What is the expression of my lambda 1 and my lambda 2? Okay? Again, straightforward lang ang calculation. I have three equations. Two unknowns ra gali, no? Two unknowns ra ni. You can solve for the lambda 1 and the lambda 2. And I think, taga ihatag na answer daan sa lambda 1 o sa lambda 2. Uh, see that's here. Nara. I will put the answer. Okay, I will put the answer for the lambda 1. Di na lang, no? Di na ako sulat ang sa daan. Basta ang nyo answer for lambda 1 and lambda 2, it's just a function of m, g, r, and k. In this case, no, may k. Yeah, k is just a constant. Okay, k is just a constant. Ano may k phi. Anyways, k is just a constant. Okay, k is just a constant. Okay, so your lambda 1 and lambda 2 must be function of um, m, g, k, and r only. No? Ano lang tulo. m, g, function of m, g, r, and k. No? Function of m, g, r, and k. R and k. Okay? So that will be your function lambda 1 and lambda. Okay. So that's it. That's it. And then I will go next meeting. I will go to Hamilton's equation. So muna ang last ata. You can see here. Napay D'Alembert's pero di na nato niya pila ng D'Alembert's principle. Let's skip this one. We will go to Hamilton's equation. This is the last topic for the Lagrangian mechanics. Hamilton's equation. The one in last. Okay, yeah. Moving last na topic sa Lagrangian mechanics. Okay. Do you have any questions?